Time to set up. Okay, do show me the video.
Oh yeah, I need to set up my video.
All right.
Before that, we are doing physics, right?
We are. Let's start with that. Yeah, let's start with that.
Yeah. Okay, because like the whole main point is that chem is like the whole thing is chem is harder, but physics there's more to cover.
Okay, tell me more. Tell me more. Yeah, tell me more.
Okay, so for physics, the topics that I'm currently unsure of is dynamics and kinematics. But for chem, the topic that I'm unsure of is the whole mole thing.
Right.
It's a big topic and it's quite complicated, at least in my opinion. The balancing equations, everything is quite difficult.
Okay. I want to have a feel. Yeah, I want to have feel. Again, Jamboard. We will now have a different Jamboard for let's say we create science. Okay, combine. So you're going to create that and share with me.
Okay. What's today's? Okay, so but we start with today's date, right?
Today's date, all right, and then say science.
Okay, I'll share with you. Okay, I'll share it.
For AMAT, I am curious. So it has the class started, AMAT, the new worksheet?
Oh yeah, you know they already covered what we've done and more.
More, really?
Yeah, we just started on the simplification something. I've lost track again.
Wow, that's too fast.
It's so fast. I don't understand.
This is unnecessarily fast. This is what? Very unnecessary and very unnecessary.
But to be fair, they didn't cover the homework while we did. Like he's gonna give us the homework over like the weekend probably.
Okay. Right. Again, we shall never be rushed. No matter what the teacher do or the class do, we shall never be rushed and we shall never be slow. Also. We will do in the appropriate pace, right? In this case, right? I hope you have enough experience to these few weeks to resist being rushed. Don't know lah. It's okay.
Yeah.
Right?
I'm just coping things down and just hoping that, like, you know, when tuition starts again, I'll be like.
Yeah. We'll definitely do that. We will definitely do that.
Yeah.
Yeah. But there will be consequences in rushing one for the class. There will be one. It's that one is very clear to me. Yeah, that's good.
I think I'm already gonna be better than my class.
Your audio is breaking up, yeah? Your audio is breaking up.
Oh, okay.
Right.
Sorry.
Okay. Testing. Can you hear me?
Yeah.
Okay. I can hear you also. Do you have the new Jamboard?
Yeah, I've shared the Jamboard with you already.
Okay. Okay, I'll put the science in front. I think that will make things easier.
Thank you. Sure.
Okay, all right. Okay, so again, waiting for your video, yeah. And AMAT is like that. And having said that, even though you might not be ahead of what they're talking about, right?
Yeah, not at all.
However, I don't think you will miss the whole, because it is the next few pages are a continuation. That is the proving thing, the proving that you said.
Yeah, the proving thing that we didn't even start on. We didn't even do proving.
Correct. As in we in tuition or we in class?
Tuition.
Right. But proving is a continuation, even though it feels new. So yeah, so we'll find time to talk about that. Okay, now again, I'm waiting for your video.
Oh yeah.
Right. Just in case I would need them. Yeah, most probably I'll need them. You do sound fresh today. Is it true?
Oh yeah, I'm decently so I just haven't done much work today.
All right. Okay. All right. Okay.
Only thing is the lack of sleep. I'm running on 3 hours of sleep.
3 hours is it's damaging for you. No, it's bad. It's bad. Preferably you don't sleep less than 7. As impossible as it might sound, your intelligence and your health needs 7 to 8. Yeah, 7 to 8. So
I mean, usually on weekdays I sleep 3 to 4 hours. Depends. I mean, sometimes 4 to 5 hours.
No. I don't know how to fix that, of course, but I wish you will have a life where you can sleep more. Does your father sleep that little also?
He goes to sleep later than me, but wakes up later than me. So I'd say yeah, about the same, maybe a bit more.
There are long-term consequences on lack of sleep. Okay, never mind. Never mind. We'll talk about that. Okay, so I see your video and everything, and so I'm gonna have a feel. Okay, the goal today for me is not to teach you something new, although I think that will happen, or rather to clarify doubts. I think that will happen, but I want to really have a feel of you with science, lah. Okay, in this case, chemistry, right? That will be my goal for today. Do you have any specific goal for us today?
Today, I know I'm the same as you. I just want to feel and see how we can move it forward.
Okay, all right. Now, different subject. Although we are the same person, in the learning process, you will expect certain things to be different, right? In fact, treating all subjects to be the same it's a recipe of failure, like at least in my eyes. Yeah. So now, I will start with a mole first because not because physics is not important, not because, but mole is central to everything from the moment mole is discussed. So it is not an option to be confused with mole. Mole is not separate. Mole and balancing of reaction is everything the moment it is taught. Okay, yeah, right. So I want to use this a critical topic to have a feel, right, of your science, right? So please have a paper, right? So you have to write a Jamboard. Just a blank piece of paper is fine.
On a Jamboard, you mean a foolscap?
Yeah, just on the video lah. So paper, pencil, so that you can respond to my request.
We're doing physics. I'll do the physics.
But a blank piece of paper is fine because this is again feeling things lah, right? Like feeling things.
Okay, I'm gonna. Okay.
Okay, yeah, right. Okay, so mole, yeah, mole. So I want to be very clear with you what they meant by mole. It is a very simple thing. Okay, it's a very simple thing. Yeah, very simple. Now I have the word molecule, and then I have the word mole, right? Mole is not a short for molecule. It's not. Yeah, it's not. So, but I will use the word molecule first, lah. Yeah. So I will write a very simple reaction. Ainesh, H2 plus O2 equals to H2O. This is me burning hydrogen gas. So I know this is a gas. I'll put that as a gas. I'll put it as a gas, and here I put this as a water. Right? Okay. The reaction is not very confusing. Ainesh, yes.
Yeah.
All right. Now this reaction is wrong or is missing something. Okay, so using the best of your knowledge, Ainesh, is this guy wrong? So hydrogen.
Hydrogen plus oxygen.
One more time, the elements. The hydrogen gas, is there something wrong with it?
No,
All right, I agree. Oxygen gas,
nothing.
a water molecule,
It's good.
the arrow, burning of hydrogen gas will produce water.
Yeah.
No problem. So I am not kidding you. I'm not testing you when I say there is something wrong or missing here. Do you know what that might be?
The numbers of molecules.
Wonderful. Can you fix that for us to the best of your knowledge?
And here's where I face the issues.
All right. Now, don't worry. Don't worry. Don't worry. I will now draw. I will now draw. No, in fact, I'm supposed to show you a video, which I can't. But that's bad. I'm supposed to show you my video. That's the easiest way to teach this, right? Okay, you gotta put one here, you gotta put two there, and then that's it, is it? Is that the fixed thing?
Yeah, 2, 1, 2.
Oh, 2, 1, 2, 1, 2. Wonderful. Now, before we conclude you're right or wrong, I will draw. I will draw, yeah? I will draw. So oxygen is kind of big, double bonded with another oxygen. That is your oxygen. That is your oxygen molecule. Looks like that. Hydrogen is a bit smaller. So single bonded, another single bond. Okay, I just draw two hydrogen molecules according to your number. Yeah? Now I will draw two water molecules.
Okay.
All right. So look at this, look at that, and this becomes that. That's the claim, right? Simple, right? Simple stuff. Visually, does all this make sense?
Yeah.
Okay, now I will pretend that you never put the number. So when we don't put the number, we basically assume 1, 1, 1, no? Correct?
Yeah.
So here's 1, and then here's 1. Okay? 1, 1, 1. Does it make sense? If it is truly 1, 1, 1.
Yeah.
Does it make sense? You say yes. Correct? You say yes, 1, 1, 1 makes sense. So 2, 1, 2 also makes sense. Both make sense.
Well, actually, no, it doesn't. What happens to the extra oxygen molecule?
Precisely. Now we go back to 2, 1, 2, right? Why does 2, 1, 2 make sense?
Because then all the molecules are involved.
Right. Now, the word that you use is wrong, but I understand what you're saying, right? Everything is accounted for. I'll put it that way.
Yeah.
Okay. Now, to mess you up a bit. Now I'm messing you up. 3. Okay, 3. So, I mean, I should draw 3, right? There you go. Does this make sense or not?
Okay, yeah.
This makes sense. 3, 1, 2 makes sense.
No.
Okay, why?
Because then all the things are accounted for.
And who are not accounted for?
The extra 2 hydrogen molecules.
Right. So you're saying the extra stuff on the left-hand side, which is lost on the right-hand side, and our chemistry does not allow that to happen. Things don't disappear. In the real world, things don't disappear. Okay, to be fair. So in chemistry, things don't just disappear. The bond may change. The bond may appear or disappear. The stuff may not appear or disappear just like that. Right? So far, are we using logic or math or science here?
Logic.
Yeah. This part of chemistry is simple logic. Things don't just appear or disappear. They must be accounted for. It is, in some sense, simple math. because accounting for is using simple math, no fancy math at all, like trigonometry, very fancy math. No need. No need physics math, no need. Okay. This is, by the way, the heart of the mole topic, by the way, which is therefore the heart of chemistry topics from now on. It is just like that. Simple things accounted for. All right. Now, let me mess you up a bit more. 1, right? 1. We're back to 1, 1, 1. And you say certain things are not accounted for. So I now do half lah. 1/2 1.
Half?
Yes, 1/2 1. So is this okay or not?
That's not even possible, right?
But, okay, I'll test you, yeah? But all things are accounted for.
Oh, yeah, but the oxygen doesn't stay in one state. Like
Oxygen don't just become half, is what you're saying now.
Yeah.
That's chemistry. That's chemistry, lo. Okay, that's chemistry, lo. You are right, lah. You don't just cleave oxygen molecule like that one. Oxygen O2 doesn't just become O. That's not how chemistry works. There's something wrong if we think that way. Good, that's chemistry, lo. That's more than simple logic, right? That is chemistry understanding, right? So okay, now we have 2, 1, 2. Just to be clear, can I have 4, 2, 4?
Yeah.
Okay, lah, that's not a problem. Can I have, 2,000, 1,000, and 2,000?
Yes.
Can. Okay, so now the word that you're looking for is, by the way, atoms, not molecules, because molecule talks about this whole package, but this one is all atoms. So all atoms are accounted for. That's what I'm saying. Okay, yeah. Now, before we talk about the word mole, we are already talking about mole. Just never realized that. I'm going to put mole behind. Okay, so I'm going to use the word many, many lah. So many can be, for example, thousands. Many can also, for example, billions. So now, just to be clear, can we do 2 billion, 1 billion, and 2 billion?
Yes.
Can we do 1 billion, half billion, and 1 billion?
Yeah.
Okay, then that 1/2 1 makes sense as long as you are not cleaving the molecule. It's not just one molecule, half molecule, and one molecule. If it is 1 billion, half billion, and 1 billion, totally makes sense, correct?
Yeah.
Now, if it is an ugly number, now it's an ugly number. So ugly number, I don't know, let's say 0.752 million of oxygen molecule, of course. Is this okay?
I guess. Yeah.
Provided.
Provided as an even number.
I mean, odd number also can work. Okay, I'll make it odd. Look, I'll make it. I mean, I'll make it look odd. It's not actually odd, yeah.
Yeah, I mean, if the number is actually odd, including the millions.
Okay. So instead of that, I'll go 751. All right, that's quite a lot, lah. 751 oxygen molecules. Okay, no?
No.
Okay, of course it's okay. Provided. Now look at my provided. Look at my provided. Provided, right? Provided I have 2 times 751 hydrogen, and I produce 2 times 751 water molecule. Provided.
Oh, okay.
Does this make sense or not?
Yeah.
Are you sure?
Yes.
We are almost in mole territory. We are almost done. We're almost done. Again, are you sure?
Yeah.
Okay. So mole is super many. Super many. There is a reason why it is that super many. I'll tell you the story very soon. How many? Knowing your school, they might give you an accurate number, so like that. Okay, 6.02 times super many super many Okay, super many what? Whatever you want. Super many molecules. Super many atom. It just depends on what
So
you
that's
can
an
use it for.
Avogadro number.
I'm sorry. Yeah, that's an Avogadro number.
Yeah.
So 1 mole is one super many amount of stuff called Avogadro number, which has a reason to exist. It does, yeah? It does. So 1 mole, can I react one super many stuff of hydrogen molecule? Can or not?
Can,
Provided
provided that half of it is oxygen and the same number.
half mole, we call it half mole, right? Just for short, right? Instead of writing this, and then it will produce
the Avogadro number of moles for hydrogen.
1 mole, right? Okay, of water, of water.
Oh, sorry.
Right. Now, this is actually the heart of mole. There is 1 mole. This is okay or not for you?
Yeah.
Okay, now let me test you then. Now we are using mole. Remember, mole is just Avogadro number for whatever we want. Just a shortcut for a big number, right? Okay, so can I 3 mole, 2 mole? Can or not?
No.
Not wrong. How should it be correct then? How should it be corrected?
It should be 4 moles and 2 moles.
I'm writing your answer here. 4, 2. There is another option.
Yeah, make 2 moles into 1.5.
Very good.
Which is the correct option because I know there's a term for it which I forgot. We were doing that in class.
Yes.
I can't remember what it's called.
The logic is sound. I mean, it's simple logic, but it's very sound. Meaning, hey, I mean, I have maximum 3 lah. Don't ask me for more lah. Something like that.
Exactly.
I have maximum 2. So I think I will choose 3 and 1.5 instead of 4 and 2 because I don't want to ask for more. Unless the question states I can know. Okay. So both are correct, by the way, as long as you don't assume you can just ask for more. So usually this is wrong, but that's just a limitation instead of truly wrong. Okay. Even that you understand. Even this you understand. Even this you understand.
Yeah.
So let's say this is not the usual option, not because it is wrong, but because we don't ask for more usually. Yeah, usually. Now there is a term for this simple stuff. This guy is excessive, meaning excessive or excess simple. Just go for excess, right? And this guy is limiting. No? The limiting guy is the nicely used up. The excess is, of course, we have more. Does this confuse you? This Ainesh, that 2 is a smaller number than 3, but 2 is excessive.
No, it doesn't. I understand.
All right, sure. So excess and limiting question are also very normal, and it happens in lab every time. In lab, we can never be very accurate with our measurement. We are human beings. So there will always be some excess a little bit unintentionally. Like maybe in lab we will get 3.05 and 1.49. Okay, which in this case, very ugly number, but unintentionally by us, who is excessive and who is limiting.
Three is limiting and 2 is excessive.
This guy is excess? This guy is limiting?
No, vice versa.
Oh, all right, okay, I'll write it down. Okay, so in lab, let's say we wrongly measure 3, again, unintentionally. This will be your excess. No, I'm sorry. This will be limiting, is it? This will be limiting, you're saying? And this one will be excess. Again, we don't meant to do this, but we cannot measure 1.5 correct? This is what you're saying? Yes?
Yeah.
In this case, you are wrong. I am pretty sure it is the other way around, and I'm not bluffing you.
Yeah.
Can you see why?
Yeah.
Why is that?
Yeah, I understand.
Mm,
Do you want
I'm
me to
saying that this is limiting, I'm saying this is limiting in this case. This is excess.
Oh,
I'm saying that you are wrong in this case. I'm saying I'm not bluffing.
what? Whoa, okay.
Now, I just show you using numbers. It's simple logic. It's simple but sound. Yeah, it's simple but sound. So if I want this to be limiting, I require half of 3.05, right?
Yeah.
Which is
More than
not what
1.4.
yes.
Yeah.
So this cannot be limiting. So I limit this. I require what? I require 2 times 1.49 here, which is definitely I have more.
Yeah.
So I'm just testing two sides. All I do, I just test both, Actually, I don't do much thinking except that lah.
Yeah.
Now, all this testing and thinking requires the number 2, 1 lah, and later on 2 also. And that's why we have to balance the equation properly lah.
Yeah.
Okay, so balancing is important and it is inseparable with mole, right? Excess limiting is just a reality of the mole topic. So far, so good, yada, yada, papaya. Any questions so far?
No.
Right. Now, I'm going to give you an equation which is harder to balance, and I'm going to explain why it is harder.
Okay, sure.
Yeah. Right. So go to page 2. Okay. This is not very hard if you do it correctly. Okay. So you may accidentally do it correctly, and therefore it is easy. Please try your best to balance. In page 2, yeah.
Yeah, no, I'm looking at it. Oh. Okay. Yeah, I'm actually quite bad.
No, it's not. Yeah. Okay. Yeah. Are you trying? Do you want to try it? I mean, at least you can try something for maybe 2 or 3 minutes.
Yeah.
At least give it a try. See what happens. This is not the topic you want to be weak at. Definitely not. Yeah.
Yeah. I don't know. I put
Okay.
1666.
Okay. Right. Now, we should discuss why it is right or why it is wrong. That's the important thing here, yeah? Now, so thank you for trying first. I'll put down your number, yeah? So 1666, right? Correct, yeah? Right, now, a few things, Ainesh, please understand this. There are 4 elements or compounds here. So obviously, like 1, 2 becomes 1, right? 4, 3, 4, 4 things. But accounting wise, we only account for 3 things. We are not accounting for 4 things as shown to us here. That's wrong. Okay, let me make this very clear what I mean. Your 2H2 plus 1O2 becomes 2H2O. There are, 3 elements or compounds here, correct? But you're only accounting for 2 things. Do you understand what I'm saying? What are the 2 things?
Hydrogen and oxygen.
Yes, precisely, more precisely, the amount of hydrogen atom and the amount of oxygen atom. 2 things, not 3.
Yeah.
There you go. Right? Again, when I draw it, it becomes very obvious. So if I could just draw this, both you and I can see directly whether it is right or wrong. But I'm not going to draw it. First of all, I don't even know how to draw this. Right? Now, I'm going to do another way to ascertain. Right? So what is it that I am accounting for here? What are the 3 things?
Oxygen.
The what? The what?
Carbon, hydrogen, and oxygen.
Very good. Now, watch. Strategically, carbon, only 1 on the left-hand side, only 1, and 1 on the right-hand side. Compare that with oxygen. Oxygen, 2 on the left-hand side and 2 on the right-hand side. Correct?
Yeah.
And then hydrogen, again, for comparison, 1 on the left-hand side and 1 on the right-hand side. Correct?
Yeah.
Okay, so if I were to do this, I will immediately ignore oxygen because it is extremely difficult to balance 2 and 2. Let's just forget about it.
Oh.
However, it is extremely easy to balance 1 and 1. Extremely easy. So I will write 1 and 6. Why? Because I don't care about the H and the O. I don't care about the H and O. I care about the C only. This must be 1. This must be 6. So far, so good?
Yeah.
Now, the second guy that I account for, who would that be?
Hydrogen.
Yes, which, I mean, strategically very easy. So another 1, right? Another 1. And this is another 6.
Yeah.
Totally ignoring the oxygen and the carbon, by the way. Totally.
Mm-hmm.
Now, do you notice that I only have 1 space left?
Yeah.
This is the part where I know my life is very easy now. Because accounting oxygen will be now very easy. Instead of 2 and 2, I can now just, balance this box. Very easy. 6 oxygen, right? 6 oxygen. 12 oxygen, 6 oxygen, correct?
Yeah.
So this should be 12, right? 6 plus 12 equals to 12 plus 6. Simple, right?
Yeah.
So my answer will be 6. And so you are correct.
Let's go. Actually, I was trying to balance oxygen first.
Nonsense. Totally unnecessary. I can do this in 2 seconds because I know which one to balance first. True. Which one to account for first, basically.
Yeah.
166. Okay, 6. Done. Okay. That's, I think, what you're missing. That's what mostly people miss. I don't know why they don't teach it that way. It's simple accounting. It's counting beans. It's counting things. It's simple, right? Simple. Now, I'm going to give you something that looks complicated. Okay. You're going to balance it.
Okay.
Right. So, what's the most complicated one? Okay. I'll give you a very complicated one. Yeah, this is definitely complicated. Okay, now a word of advice first. About advice, you have seen hydrogen sulfate before. This the sulfate part, right?
Yeah.
Okay, this sulfate, you treat it as a separate thing. That means you account sulfate and sulfate, and you're not going to mix this oxygen with this oxygen. You're not going to account oxygen. You're going to account sulfate and then the rest of the oxygen separately. That will be extremely beneficial. If you understand what I'm saying.
Yeah.
Now, should I do this first in front of you?
No, I think I should try.
All right. Okay.
Jesus Christ.
Now, remember what I say, account one on the left, one on the right. That's your priority. Once you do that, life is very easy.
Oh. 3 plus 2 is arrow 1 plus 3.
Oh, sorry, I'm sorry. What? I'm gonna write
3
down 3 here.
3,
2.
2,
Okay,
1,
then 1,
3.
3. Okay. So now I'm just gonna do my own way, right? Just gonna do. Hey, SO4 and SO4, 1 and 1, 3, 1, right? Right?
Yeah.
Hey, that's it. Hey, aluminium and aluminium, right? 1 and 1, 1 and 2. Look, I'm left with one box. I am very happy. I'm a very happy person.
Yeah.
Okay, so notice that in my last box, I need to account for two things. It's very weird. I need to make sure that my hydrogen and my oxygen balances. It shall happen. It shall happen. It shall happen. So I am left with what? I have 6 hydrogen plus 6 hydrogen, right? I have 6 and 6 hydrogen. Correct? Am I correct? So I'm supposed to write 6 plus 6 divided by 2. 8, 6. I think I'm supposed to write 6 here. I think not 3. I think considering that there are 6 hydrogen and another 6 hydrogen, considering that. So 12 to be accounted by him. So 6 times 2. Pretty sure about that. But the real test is whether I account the oxygen properly or not.
Yeah, exactly.
Did I? So because I don't have to worry about this oxygen, remember this is accounted here. All right.
Yeah.
I only have to account for this oxygen. How many is this oxygen? 3 times 2. They are supposed to be 6 oxygen. Did I account? Yes.
Oh, damn, I forgot about that. Oh.
Right. Now, Ainesh, what I'm saying is this, as long as you do 3, 1 and 2, 1 first, you are 80% to the finish line.
Yeah.
As long as you prioritize the proper things first, the rest will fall. You just have to calculate a bit more carefully. Did you prioritize 3-1 and 2-1?
Yeah, I did.
Good. And
But
then you have the final box, right?
you mess up with the oxygen.
You make the error on the final box, but you are already 80% correct. That is what I want to teach you, the priority.
Yeah.
Final box, easy lah. I mean, you just count properly lah. That's all. Okay. Now, in the final box, let me emphasize, you are supposed to count for both hydrogen and oxygen to be certain, which I did, and I proved to you I am beyond doubt correct. My accounting is correct. I don't need to draw. This is too complicated to draw. Now, do you understand what I'm saying, roughly?
Yeah.
Now, tell me, what is missing from your school? Like you seem to understand many things as far as I can tell, but you cannot complete it all. What's going on here? What do you think is going on here?
Okay, firstly, the balancing equation, the thing that he just taught me, I couldn't do it earlier, so I had issues with that. It's more about application. I feel like I know my stuff. It's more about application. That's why I asked for science in total, because my chem is not bad, my physics is not bad, but I want to elevate it to the next level, because the material I have right now for my sciences is passing level, but like my knowledge on it, I want to actually do well for sciences. That's why I said it's a lot different to my math, because when I came to you with my math, it was definitely failing. I wasn't going to be able to pass if I didn't achieve.
Are you saying that you cannot pinpoint a certain problem with your science, but you know you want your science to be better?
Yes, it's just my applications especially. It's because I've had no practice so far. I just know like the basics. Sometimes I don't even know the basics.
Fair. And I haven't finished with the more basic. I haven't, but I do reach the most complicated balancing. I would say, and the technique is important. I do feel that as per usual, your teacher doesn't seem to teach the technique for the harder one. They just let you figure it out yourself.
Precisely, yeah, I really hate that. Yeah, but the difference between math and the sciences is that sciences actually go really slow.
So that's good in class? Is that good?
Yes.
Supposed to? Okay.
It's better than fast. Slow is better than fast.
Oh, definitely. I totally agree with you. Totally agree. So you're saying that the sciences classes are better than the math classes?
In terms of speed, yes, because it is in terms of concentration, no, because math is so insanely fast, I'm forced to concentrate the entire time. Doesn't mean I understand anything, but I'm still forced to concentrate. For sciences, I can afford lapsing out of concentration for like a solid 30 minutes, and I still wouldn't miss anything.
But I do sense some gaps.
Yeah, I think that
I do.
Yeah.
There are gaps in basic, but to be fair, you get some other basics correct, but there are still gaps in the basic.
Yeah.
I mean, as per math is a big hole. So I suppose they are different. I suppose.
Yeah.
Right. Okay. Right. Okay. Now, do you want me to continue with the mole? Because there are more things to cover, or do you want me to continue? We don't need to switch to physics today.
I think let's just do chem today, then we do physics on.
Okay.
Actually, no. I think we should do math on Wednesday, honestly. Math is going really fast. I think we do math on Wednesday.
Okay.
Yeah, then we do physics on Thursday. Okay.
Fine. So page 3, Page 3. Okay. So this is the other basic of mole, which it's not an option to be confused. It's not. This one has to be very, 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 very clear. Okay, right. So solid equals gas. I will ignore liquid for now. So this one is for now ignore. Okay, so just solid equals and gas. And of course, I'm referring to they call it the phase line. The point is in room temperature, are they solid, aqueous, or gas, or liquid? Okay, yeah. So for example, I'm giving you a gas here, right? And H3, right? You may know this as ammonia, right? So some memorization. Ammonia is gas in room temperature. Now, what do they give you usually? And how to convert it to mole?
There's the three formulas I need to know.
True. 3. Yeah. Now, I don't care about the formula. The formula has a meaning, but of course, teacher will teach it as memorize this formula and use it properly. Now, don't look at your formula, okay? Don't look at your formula, please. Please don't. Please don't. I'm asking your not logic. I'm asking your common sense. It's just general sense of things. I'm not even asking you to think too much in terms of chemistry. I'm not. Now, when you want to have an amount of gas, right? When you have to have an amount of gas, what do you usually measure it in? Let me give it. Give you an option. You're gonna have a weighing scale. That's one. 2, you're gonna have some sort of volume measurement stuff. I don't know how you would measure a volume of a gas, but somehow you measure the volume of the gas. There are multiple ways to do it. Or you can somehow have some other thing to measure. I don't know, maybe you can measure concentration, maybe if that is possible. I don't think it's possible, but let's say you have a device to do that. Now again, back to gas. Just common sense, okay? The most convenient thing to measure gas is with?
Mole.
Nonsense. We don't have a mole meter. We never have a mole meter. We don't measure mole. We calculate mole. That tells everything about mole. We cannot measure mole. We can only calculate mole for something else. Which begs the question, why do we even bother with mole? But, I'm not going there yet. Again, this is a certain amount of gas.
Yeah.
This is a certain amount of helium. This is a certain amount of nitrogen. I don't know, for your party purpose. Nitrogen is laughing gas, and also sleeping gas, right? Helium is balloon gas and also making other people laugh because your voice is very chipmunky test, right? That's kind of gas. I want to sell you helium, right? I'm a helium dealer. Okay, I sell you. You are the party clown. Okay. How do I sell you the amount of gas? You're gonna ask me in what kind of amount? No idea? No.
No.
Are you going to buy from me something like this? 10 kg of helium gas?
No.
Why not?
Centimeter cube.
Yeah. It's gonna be in volume. Because that's just naturally what we do with gas. Volume lah. Give me a volume lah, meaning to say, give me centimeter cube or decimeter cube, right? Or decimeter cube. Now, normal people don't say centimeter cube or decimeter cube. This is not normal. What normal people do, like common people. Common people say what? In terms of volume, there's another more common. Centimeter is not volume, please.
I mean centimeter cube.
Yeah, but normal people don't say give me 100 centimeter cube of helium. That's the normal people do what? Yeah, does your father or mother, which is not a chemist, right, say that? Aryan, go and buy 1 decimeter cube of gas, helium gas, for your party. They don't. So what is the more normal thing to say for normal people? Okay, I'm going to say something here.
I don't know.
Gas and liquid are treated the same for normal people. So let's say I want you to buy water lah. Do I say to you, Ainesh, go and get us 10 decimeter cube of pure water?
No, I mean, you say like get a bottle of water.
Correct. If I want to be a little bit more precise, I will not use bottle, but I can use how many bottle? Oh, liter. Yeah. Normal, not liter. Okay, slightly less than that. If I'm into baking, I'm going to use milliliter lah. Baking or cooking lah. right? I can use teaspoon or all those stuff, but liter and milliliter are normal people language lah.
Yeah.
Very conveniently, 1 decimeter cube is 1 liter, 1 centimeter cube is one milliliter. Very conveniently, huh?
Yeah.
So just say, right? So you know all this, yeah?
Yeah.
Now let's settle the solid one first, lah. So I'm gonna buy, you are now a gold dealer, you buy and sell gold. Okay, let's say I'm getting married, right? I'm already married, but let's say I'm getting married and I want to propose to my girlfriend. I go to you lah. Okay, buy gold, solid. Do I say, can I buy from you 3.5 milliliter of gold? Do I say that as a normal person? Ainesh, can you hear me? Sorry, Ainesh. Ainesh, can you hear me? Ainesh? Uh-oh. Ainesh? Ainesh? Can you hear me?
Hello. Hello.
Can you
Hello.
hear me? Can you hear me? Ainesh? Ainesh?
Oh. What's going on?
Ainesh, can you hear me?
I don't know what to say.
Okay, testing. Can you hear me, Ainesh?
Yes.
All right. Okay. So yeah. Okay. Right.
Yeah, what were we talking about? The last thing I was hearing about was liters. I thought you went on mute.
Right. So I was talking about solid, and from a normal people perspective. Yeah, that's what I'm doing. So gas, normal people perspective lah, milliliter, liter, no? Right? Solid, normal people perspective. Can you hear me? Testing.
Yeah.
Okay, good. So I'm asking you to become a gold dealer. Okay, gold dealer. You buy and sell. Okay. Your friend wants to get married lah, and he's proposing to his fiance. Right? Hopefully she will accept. He go for you to buy gold lah, to make rings or necklace or whatever she fancies. Does your friend say to you, hey Ainesh, can you sell me 20 karat gold, right? 3.5 milliliter, please. Does your friend say that?
No.
But Ainesh, I thought every solid has a volume, a fixed volume some more. Why don't normal people say that? Sell me 3.5 milliliter of your gold, please, Ainesh. Best price for me, lah. I'm your friend, okay?
True.
Why don't normal people do that? There is a reason, okay? It's not that normal people are stupid. No. There's a reason why normal people don't do that. Same thing as why don't normal people say you go and buy 3 kg of water? They don't say that. They say go and buy 3 liter of water.
True.
Why don't people use, solid with volume? Why don't they say gas or liquid with mass? Why don't? Although obviously both have both.
Is this SI unit?
No. SI unit, nothing to do with this. Again, solid and gas both have mass and both have volume. Correct?
Yeah.
But if your friend is buying your gold, he will not say 3.5 milliliter, but he'll say something else. What will he say? Tell me
Carat.
this. No, carat is the purity. No. Of course, he has to specify the purity. I understand that's concentration. But how much he will say, okay, hey, you're gonna ask your friend, okay, how many carat? Okay, your friend say, I think I will afford 18 carat. I don't work for long, so I think I'll go for 18 carat. So purity, look. Then you will ask him, right? How many? What is the amount, right? How many gold you want to buy? Correct? You will ask him, right?
Yeah.
And then he will say, enough gold to make one ring. And then you will say, because you're the experienced person, you will say, oh, that will be a certain amount of gold, right? Now, you have to decide in what unit you will say as a normal person. So what will you say as a normal person? As a normal person, Ainesh, you will say in what unit?
For liquid, right?
No, for gold is solid.
Yeah. Oh, okay. I think okay. For solid volume.
No. You're not gonna say 3 milliliter of gold. You're not gonna say that. That doesn't
Cubic
sound.
meter.
No. 1 cubic meter is super big gold, and nobody will buy that amount of gold also. But also, it doesn't sound normal. Okay, it doesn't sound normal.
Yeah.
Let me give you another example. Okay, your mother asks you to buy rice lah. Okay, rice finish lah. Okay, rice finish. You go to the nearest convenience store and buy rice. Your mother will say, buy 1 packet of rice, Ainesh. Okay, and then you, so that you're not wrong, will ask your mother, what package? And your mother will reply,
1 kg.
precisely. Kg or mass is what we use for solid, normal people.
Yes.
So your friend asks you to buy gold, and then you ask how many amount, and then, he say enough to buy 1 ring, and then you say, oh, that will be certain amount. What is the amount you will use, and what is the unit you will use? Not kg. People don't buy 1 kg of gold. Smaller than that.
Yeah.
So please, your friend is waiting for your answer.
One kg.
No, less than 1 kg. People don't buy 1 kg of gold for jewelry. Less than that. Less than 1 kg.
0.5.
Definitely less than that. Definitely less than that. Go lower.
0.01.
All right. At this point, 0.01 kg. Better, more convenient. We don't use kg. We use
gram.
Yeah. So please convert.
So 10 grams.
Okay, 10 grams. Okay. Actually, this is for my experience. It's actually around 3 grams. 3 grams. Right. So you will say to your friend, okay, 3 grams, give or take lah. Right. Depends on the ring lah. Right. Hopefully your fiancé finger is so big lah.
Yeah.
Okay. That settles my point. Normal people say gram or kilogram lah. Simple lah. For solid lah. You may not know why we use that, but that's just normal though. Or normal people, gas and liquid use volume lah. Normal people solid use gram or kilogram lah. Don't give me volume for solid lah. Does not make sense to me. Something like that.
Yeah.
Okay, clear?
Yeah.
So in chemistry, that's what they do. The question normally give you for solid gram or kilogram. Just like normal people.
Yeah.
And for gases, although normal people don't buy and sell gas, just imagine them as liquid, The question will also give you in centimeter cube or dm cube or liter or milliliter. Same, just like normal people. Okay, now the last thing, solution. You don't think normal people buy solution? I'm guessing, but normal people buy solution every time, every day in their life. Near you, near me. For example, which one do you like? Starbucks, Coffee Bean, Tea Leaf, or I don't know, the 7-Eleven Slurpee. I don't know. What do you like? You can like something else, okay? But what do you like?
Milo.
Milo. Wonderful. I also like Milo. My wife likes Milo. Now, whose Milo is your favorite? You must have a favorite one. When I say who, I mean who make one. Who make is your favorite?
I mean, I guess the one you can make at home.
Yeah, but who make it for you?
My mom.
Your mom. Because if your father make the Milo for you, he
He doesn't.
He doesn't. And if he does, which is a very good day for you, his Milo might not be as good as your mom's one.
Yeah.
Right? So, your mom's Milo, she make very nice for you, lah. Right? Okay, now, solution. We're talking about solution, yeah? Milo.
Yeah.
How do I say this? Isn't Milo a solution? Meaning, one packet of Milo, right? One packet of Milo. Okay. We use a cup, right? We use a cup. She knows your favorite cup or your favorite measurement, how small or how big. Is it possible for your mom to make the Milo with too little water or too many water?
Too much.
Too much. How does a Milo with too much water taste?
Just diluted, very diluted.
Absolutely, and we don't like it.
Yeah.
I'll take it like this. You would prefer for it to have too few water, too less water than more water.
Yeah.
If you're gonna make a mistake, make it less water than more water.
Yeah.
In fact, most people tend to say that. Do you know why? That's kind of just normal. Yeah, if you don't know what my name, make it with less water. Again, do you know why?
Because then it will be tasty.
If it is less water, it will be
Less
tasty.
diluted. Yeah.
Yes,
Yeah.
diluted. Okay. And since you taste it a bit, it's too concentrated. We'll say that, hey, too little water. It's easy to fix what?
Yeah.
How to fix?
Just add more powder.
No. It's too concentrated. Hello, Ainesh. Hello,
sorry.
hello.
I mean, add less powder.
No, you cannot take the powder out of the Milo.
Then just add more water, I guess.
Precisely. Easy to fix, man. Right? Easy to fix. I tell you, even better. Even better, you add more ice cube. And you let it melt. And then you have more water, but also cold. Better. But if your mother make too much water already, how to fix?
Then you add more powder, I guess.
Theoretically, you add more powder. But don't tell me you have a can of Milo at your house. What you have are packages of Milo.
Yeah.
Do you mind if you add another package of Milo?
I guess I'll just add like half of it.
Then what to do with that half? It's not convenient, it's not convenient. That's what I'm trying to say. Normal people, why don't we just make it correct at the first place, right? Okay. Of course, you are right. Theoretically, in the lab, in chemistry lab, if I make it too diluted, I just add more of the stuff, right? Like theoretically, but it's inconvenient to do that. Inconvenient. Yeah. It's better to start with less water and then we add until it's correct. I think that's a better way of doing it. Okay. Yeah. Something like that. Now, don't normal people pay special attention to solution? Is what I'm trying to say. You pay special attention to your Milo. Now, your Milo concentration looks like this. Amount of solid over amount of liquid. For example, one packet, which is the solid, over this certain small glass. So, for example, or my medium glass. The medium glass, I'm not talking about the glass, I'm talking about the volume of liquid in the glass. So, solid over liquid glass. So, use one packet of Milo with this glass. Not the small one, not the big one, something like that. Okay?
Yeah.
So, in chemistry, what kind of unit do they give you in solution, for solution? They give you gram over centimeter cube. Which is not what normal people use, but I hope you can see the similarity. Like it is solid over liquid. That's what most normal people care about. in concentration or in solution. That's why concentration have this unit. Can, yeah? So first put it. Now, all this formula is meant for you to change the normal stuff into mole. Now, my question is this. Why bother? That's my last question for you today. Why bother changing the normal stuff, happy with this, to mole? Why bother?
It's like math again. Just try to have the same thing for everything. Like
Then,
in math for trigo, you have to get like all the same for everything.
Then I have a better solution. But now, of course, you are making assumptions. Right? You are making assumptions, right? But therefore, a better solution is this. Look. I propose to you. Don't change the gram. Just change the centimeter cube into gram. I just change one thing. So now I have gram and gram. I can do that, Every liquid can be changed into gram. It's unnatural, but I mean, better than changing this to mole and changing this to mole. What? I just change one thing. Good what? So why don't we do that in chemistry? I can do it the other way. I maintain the centimeter cube for the gas, and then for the solid, I change it to centimeter cube. I can do that.
Yeah.
So why don't we, Ainesh? Why don't we? I will now go back to the first page, and then I'm going to close it. Yeah, look at me. Yeah. Okay, so we are still in the middle of discussing why molar. Why molar is that? So I'm not give you not a molar. I'm going to give you here 2 gram. I can measure the mass of a gas one if I try hard enough. So 2 gram, 1 gram. 2 gram of hydrogen will react with 1 gram of oxygen and will give you 2 gram of water. Is this correct or not?
Yes.
This is, I think, the reason why you struggle with it. Because unconsciously, isn't using gram much easier for our life? If this is correct, why use more? Why are you making my life harder? That's your subconscious law. I think that's the problem.
Oh, maybe.
By the way, this is totally wrong. By the way.
Oh.
And that's why you learn chemistry. Why is it wrong? Then you have some motivation to use, okay, maybe I use centimeter cube, 2 centimeter cube of hydrogen plus 1 centimeter cube of oxygen will become 2 centimeter cube of water. Is this correct or not?
Yeah.
Surprisingly, this is very surprising. This is one of the things that you learn in chemistry, right? So 2 mole, 1 mole will become 2 mole. Now, the surprising thing about gas is that this 2 is correct and this is totally wrong. It's totally wrong. And there is a very good reason why. This is why you learn chemistry, not for the formula. Okay, now, I might have wasted some time here, but did I figure out certain gaps in your knowledge?
Somewhat, yeah, I guess.
Right. So one more time, you do not know why this is wrong, right? If this were to be correct, you will much prefer to use this line. Am I correct?
Yeah.
All right. Then time is up. I kind of understand where you are. Yeah, I kind of understand where you are. Okay.
I think it's a better position than math, but there is some fundamental mistakes.
The gaps that I aim for is basic. Doesn't mean that all basic is wrong. This is as per usual. You have certain gaps in your basic law, which is, I don't think it's an option. I think it tortures you subconsciously. I think if you figure this one out clearly, we spend time on it, you will have much more, freedom to think, freedom to enjoy chemistry. That will, I hope, that's what I will hope for you.
Okay. I'm sorry,
So,
I was quite tired today, especially near the end.
I know this. But this is our test also. We test, can we actually do more than 3 hours? No. tomorrow you know have tuition. So we'll see on Wednesday what will happen. Okay.
Yeah.
I hope you have still a good time today, and
Yeah.
I'll see you on Wednesday. Yeah.
Yes, you too. Have a good night.
You too. Bye bye.